there is a memory in the display. And you're going to be seeing that when you play with these. The display itself is pretty slick. It's a nice large display. It allows you to look at several things. But it has one feature on there that I hope you will all use. After you set it up and get it running the way you want, you upload the program into this and save it. That way, if you got 2 or 3 drives, you can go to the next one, just download each one. Also, and after you've done downloading, you want to take put the display that came with it back on, and then upload that program into that display. And the reason you want to do that is because someone's always going to mess with these things. I had one job where the balancer came in, he ran the speed up and down the drive and stuff like that. He messed up some parameter. He was in there playing with it, and when the contracting installer came in there, he couldn't figure out what it was. You couldn't get it back to normal, run automatically. I came down there and looked at it. I couldn't either. You know, I set it back to factory defaults and still wouldn't go back. I'm thinking, oh man. Fortunately, he had 4 drives. 2 worked, 2 didn't. So I just went to the ones that worked, uploaded the program, plugged it in, downloaded it, and we're fine. And then I uploaded the program, made sure each one of the drives had the memory in here. That way, if someone messes with it, you can just hit download, it goes back to where it was. Trust me, there's buttons, people mess with it. Also, there's a local remote button on this thing that allows you to hit, if you hit local, that means the keypad, you can make changes in speed from the keypad. Then you put it back in remote that allows the controller or whoever's running it to run. There's a stop button. If you hit the stop button, it'll stop the drive. Hit the start button, it may or may not start the drive. If the keypad is in charge, then the keypad will allow that to start it. If not, then you've got to go to whatever is enabling your drive, turn off and on. Okay, so if you have an EDC system that says turn the drive on and put on, you got to tell it, give it the command turn off and on.
So the keypad will stop it no matter what.
Yeah.
But may or may not start it.
May or may not start it.
Depending on whether it's in.
Now, if you want to start it, then from the keypad and put it back at the remote, you can do that too. So if you're playing with it, you say, how come it's not starting when I hit the start button? Well, that's very easy. Hit the stop button. Also, there's a input called fire. You can set that up so that if you hit fire, it goes up to a certain speed for smoke evacuation. You got to kill power to it to reset it. Obviously, if you're in fire mode, the last thing you're thinking of is resetting the drive. You're thinking of getting out of the building. But it's designed to speed up the fan so you can, for instance, I've seen specs where they want the motor running at 120% speed during the smoke evacuation. Drive will do that. They can make it 300 hertz and no problem at all. Drive doesn't care. It'll do whatever you tell it to do. So also speed settings is another thing I wanted to cover. It's going to ask you acceleration speed and deceleration speed when you're setting the drive up. Now, I get calls occasionally, less than I used to because they're in a lot more classes now. So it says it keeps locking out on high amperage. Well, let's take a look. You tell the motor to go up to speed, and the defaults are usually, I think, like 3 seconds. So if I say go to 100%, it'll say it takes that over 3 seconds time. It goes, fills that 100% output over 3 seconds time, gets up to speed. Deceleration, 3 seconds. It takes it 3 seconds to go from 100% down to 1. Now, the drive might take 3 seconds to get down there because you told it to. But the motor doesn't. You got a 50 horsepower motor spinning, or 10 horsepower, it's spinning away, and you say, okay, go from 100 down to 20. You've got a motor still spinning because you don't have a brake on that thing. If the motor's still spinning, what's it become? A generator. It's putting power back to the drive. The drive sees that and says, hey, my current is too high. I'm overcurrenting this motor. There's a problem. Lockout. And you go back in there, you hit the reset, everything seems to work fine. Don't drive you nuts. So what it is you've got to kind of match the speed deceleration to the motor. So for instance, if you got a large motor, 3 seconds is not going to do it. Maybe on a pump because you got a lot of resistance there. But on a fan, you might want to say, you know what, the deceleration time is 90 seconds. It's going to take 90 seconds for me to go 100% down to 0. It goes 100, 89, 88, and so on. This slowly brings the speed down. And that way it's keeping up with the fan. You're not going to have a generator effect. Acceleration, I don't see a problem with that. But deceleration, yeah, you'd want to slow down that deceleration. If you're running into that problem, 30 seconds or 60 seconds isn't enough, spread it out. Also, you have a parameter on there as a maximum amperage, alarm amperage. You could raise that. It sets it automatically based on the amperage of the motor, but you can raise that max level if you want.
Isn't raising that max level changing your overcurrent protection overall?
Yes, it is. Because that's what it's for. Now, it does predict the motor temperature. There is a input on those cards here that allow you to put a thermistor from the motor into it. So if you have a motor that has a built-in thermistor, yeah, you can hook that up to the drive. And it'll look at the motor temperature. However, what it normally would do, if that's not on there, is calculate the motor temperature based on the frequency and the ampere. So it can tell that the motor's overheating because it's pulling a lot of amperage and it's not spinning very fast. So keep that in mind. If you get a overheat thing, it's because of that, and you might want to check your amperage ratings and so on to maybe boost the amperage rating up a little bit. Now, this is I believe I put this on that flash drive. This is the product selector. So if you need to pick out a drive for a job, just click on here. There's a little arrow down. You pick the type of drive you want. Let's say I want to pick the smart drive, HVAC without a bypass. The voltage, I grab the 480 volt. Let's say a 15 horsepower. NEMA 1 enclosure. And my options, probably none there. Yeah. Here's my model number. Here's the details about it. And on the right-hand side is the base price, the list price. And you can put your multiplier in here. Let's say I think the default to 0.3, but I can put a 0.5 multiplier, and that would be the price. And you can put how many do I want, and I can tag them, say this one here is for this office, and this one's that. I can put a whole sheet together and come out with a product schedule and all that stuff. A nice little proposal sheet. But that's a nice sheet to use if you want to look at drives. If you want to compare price, you can put two different types of the same horsepower and so on and see what the price comes out to. It's on the thing. It's a very simple thing to use, and it's very quick. If someone calls me and says, I need 10 of these, 4 of those, 6 of those, what's my price? I can put it together. Here are the models you need. If I need a bypass, a 3-contact or fused bypass, whatever, you can select that here also. Something that's in that sheet with the we're going to cover a little bit on harmonics, and then we'll get put our hands on the drives. So the two major harmonics are low frequency and high frequency. And the standards, there are standards in Europe, and these are them, international standards. And those are what the drives are designed to need. We're talking access drives here, but it also applies to the smart drive. If they're properly installed, that's always the case, grounded and all that stuff, they will comply with the standards. And harmonics are just waveforms, currents, or voltages, and they're expressed in the sum. For instance, the double harmonics would be like if you have 1,000 hertz, it's 2,000, 4,000, 6,000, so on. And the odd ones are in a 3-phase system. Only the odd harmonics show up. The even ones cancel each other out.